This video is on the objective understand key terminology and concepts in hypothesis testing. And this is the second video on this particular objective. Hopefully you've watched the first one. I'm going to be going through the process of hypothesis testing again in this video because it's very important that you understand the steps involved in performing a hypothesis test. And hopefully when I go over them again, you'll also hear me define things, redefine things, and that'll help you in, when you're reading these questions. So again, I'll read this question later. Let's take a look first at, again, I'm going to go over the process of hypothesis testing. All right, and when we perform hypothesis tests in later sections, later videos, I'm going to be following these same 6 steps every single time. Right. So the process of hypothesis testing, and this is the same page I had written out earlier in the first video. Just going to go over it again. Right. So first, a claim about a parameter is made. Right, some claim is made about about some aspect of the population. I believe that the mean value of the population mean is greater than 7, or I believe that the proportion of the population that is a success is less than 30%. You make some claim about the population. And then we're going to get into this in a later objective. Based on that claim, you form your hypotheses. One is called the null hypothesis, the other is called the alternative hypothesis, and they oppose each other. They are contradictory, they are opposites. And again, how to form these hypotheses we'll be getting into in another objective, right? Another video. But for right now, first step is identify the claim that is being made about the population, and then you would form hypotheses based on that claim. Right, then identify a significance level. This significance level is called alpha, the Greek letter alpha. Looks like a little ribbon or a fish or something. Now this alpha, again, this will be talked about in another video as well, another objective. This alpha is the probability of making a type 1 error when performing your hypothesis test. Now, we don't want, we want the probability of making an error to be pretty small. So this is usually going to be either 5% or less. If it's not mentioned in a problem, we're going to have just the value of alpha be 5%. Right? It might be less in other problems, or it might actually be specifically stated. But you identify a significance level alpha. Right, then, from the population, a sample is taken, or samples, and then a number is calculated from this sample, or the samples. And you calculate this number, and this number is called the test statistic for that sample. Now, the test statistic for most of our Chapter 9 and Chapter 10 work, the test statistic will be either a z-score or a t-score, right? Z or t, or something called a chi-squared. This is chi, a Greek letter chi, C-H-I, chi-squared, or something else. And again, later on, you'll see other types of test statistics, not just Z or T. Now, which test statistic we're calculating all depends on what's the sampling distribution. Right? What's the for the mean or the proportion, which you saw in the Chapter 7 on the central limit theorem. You saw it in Chapter 8 as well when you're performing confidence intervals. Talked about sampling distributions for the mean or sampling distribution for the proportion. So if it's normal, we'll be calculating a z-score. If it's If it's a student's t-distribution with so many degrees of freedom, we'll be calculating a t-score. All right, and then, after this test statistic for your sample is calculated, you have one of two options. You can either do the critical value approach to hypothesis testing or the p-value approach. All right, so if you're doing the critical value approach, the fourth step would be to determine the critical value for that particular distribution, or critical values for the particular sampling distribution we're looking at. Now again, these will depend on whether or not you have a left-tailed, right-tailed, or two-tailed test. Now what kind of test you have, left-tailed, right-tailed, or two-tailed, we'll talk about in another video, right? This is just a basic synopsis of the 6 steps. This is not going that deep into it. And then you're going to compare your critical values to your test statistic from the previous step. And then depending on how they compare, you're then going to make a decision, whether or not to reject the null hypothesis that was mentioned earlier. So you're either going to reject the null hypothesis or you're going to not reject it or fail to reject it. And then based on that rejection or not rejection of the null hypothesis, based on that decision, you then make your conclusions. And you state your conclusion regarding the initial claim. Do you have enough evidence to support the initial claim or not? Now that's the critical value approach. And now the same 2 steps at the end are for the p-value approach as well. If you're using the p-value approach, the only difference is you take your test statistic and you determine the p-value, which is probability value, like a probability. Determine the p-value of your test statistic. And again, like critical values, this will depend on whether the test is left-tailed, right-tailed, or two-tailed, and we'll get into that in another video. What kind of test do you have? And then you compare your p-value to the significance level. You compare it to alpha. And depending how it compares to alpha, you're going to make your decision. Right? Step 5 and 6 here are the same as step 5 and 6 for the critical value approach. You're going to make your decision about the null hypothesis, and then based on that decision, make your conclusion about the claim. Do you have enough evidence to support the claim or not? So again, I would highly recommend that you click on more instruction for these problems and read through the definitions, these key terms that you're going to come across when you're performing a hypothesis test, when you're testing a claim. All right, so I'm going to read through this. All right, so a recently published medical article states that the average percent of adults who receive a flu shot every year is 72%. So this is like for the population of adults, the average percentage of adults who receive a flu shot every year is 72%. So a doctor who studies various flu strains believes, key word there, believes that the average percent of adults receiving the flu shot each year is below this published amount. So this person, this doctor, is interested in studying this further, right? Testing it. The doctor records their patients who receive the flu shot yearly and finds the percentage of those, that sample that receive a yearly flu shot to be 67% on average. So as the doctor sets up a hypothesis test to determine if their belief is correct, what is the doctor's claim? What is their belief? What are they testing? Well, they believe, right? They want to test their belief that the average percent of adults receiving the flu shot is below what this article said. So their claim would be that the average percent of all adults receiving the flu shot is below 72%, less than 72%. So that's this first statement here. The average percent of adults who receive a flu shot every year is less than 72%. That would be the claim. Right? The claim being made is always going to be about some population or populations. And the article stated that the population average was 72%. The doctor believed it was less than that, so that doctor claims the average is less than 72%, and then takes this, they took a sample. The sample average was 67%, and then from that sample, we would calculate a test statistic, a z-score, a t-score, based on the hypotheses, and then go from there. But the claim is this here, that they believe that the percent of adults who receive the flu shot is less than 72%. And read about the claim again here. Now this was like the first problem I did, the first video, right? It was about a claim. They might ask you other things. They might ask about, what would be the hypotheses or the significance level or the test statistic. But just maybe go back in my video here, watch me go through those steps of a hypothesis test again, talk about some keywords, click on more instruction again, look at the keywords, look at the definitions. But I think though most of the problems in this particular objective are about setting up, starting a hypothesis test. What's the claim? That's where a hypothesis test starts. It starts with a belief, a claim about the population that we wish to investigate, wish to test further. All right, so hopefully this helps, this video, when you're going about working on this section, this objective, these questions on your own. And thank you very much for watching.